In this lesson, we'll explore some various ways of creating chamfers on this part. Now I have a new part open called Chain Guard-1 Chamfer, and we're going to use this for this chamfer exercise. We're going to start by focusing on these two areas up here, these two pockets that we machined out previously. To machine out these areas, we're going to use a contour toolpath. And inside the contour toolpath, there's actually a chamfer function. So we'll change this back to loop, and I'm going to select this edge here and this edge here. And again, this is a contour toolpath. So besides choosing the tool, in this case a chamfer mill, and calling this standard chamfer, under the cut parameters, this is where we can actually tell it that we're doing a chamfer. And with the 2D chamfer set, we can choose a chamfer width and a bottom offset. Now the width is going to be 10 thousandths, and the bottom offset is going to be 50 thousandths. And beyond that, we can do lead in and lead outs as needed. I'm going to turn off depth cuts. Like I said, we can do lead in and lead out. And we have our linking parameters, which I'm going to set back to 0 for the depth. And when I click OK, you'll see that the toolpath gets created. And if we backplot this, and let's turn off our quick verify, you can see that we just get right into the corner and we machine out that edge all the way around and back out. Same thing over here. And again, just like any other toolpath, we can go in and adjust things, for example, like the lead in, lead out, which might be considered pretty small. So let's change that from 10 to 50 and from 20 to 50. And we'll do the same thing on the other side. Now that was a traditional chamfer toolpath using the contour as the basis. So you choose the contour toolpath and then you set it to chamfer. Now we also have an option called model chamfer. And model chamfer is a much more powerful version of the chamfer tool. And so to expand on this, let's take a look at a feature such as this down here. Now if we wanted to run a traditional contour around this edge right here, we'd have to be careful because a contour would start right at this corner. And of course our chamfer mill would hit this wall here. So what the model chamfer tool does is it allows me to select the chain geometry, and it identifies the areas where the tool will hit other parts of the design. So for example, I'm going to do a partial loop, and I'm going to start right here. I'm going to end right here. So that's the chamfer that I want to focus on right here. And in the model chamfer toolpath, we also have an option here called solid model. And by default, it sees one solid, so it selects it. But I could have selected it as well. The tool is going to be the same chamfer mill. And we'll call it model chamfer under the comment. And just like the other settings, we can choose things like the stock to leave on walls. We're going to input a chamfer width here of 10 thousandths and a bottom offset of 50 thousandths. And the same thing with linking parameters. But here's how the model chamfer really excels. When you create the toolpath and you backplot it, you notice that the tool stays away from other areas of the geometry. And the reason it does this is because it's aware of the solid geometry. So as you can see, it's getting really close to this wall, maybe too close. So what we can do is edit that model chamfer toolpath, back up under toolpath type, and add a clearance. Let's just say we want to add, let's just say 20 thousandths to it. Now you'll see when we backplot this, the toolpath stays away from the model. because of that side clearance we added. Now the model clearance works in 2D and only in 2D, but as an example, we could utilize it over here as well. So let's go into Model Chamfer, and we're going to start with a chain geometry right here, and we're going to end right there. And we're going to say the same side clearance, and for the tool we're going to choose that. We'll call this Model Chamfer 2, and we'll click OK. And the toolpath will get adjusted accordingly so it does not hit that wall. And then one last option I'd like to explore is using the Deburr Toolpath. Now that's an option that's within the multi-axis area. So if you don't have the multi-axis license, you would not have Deburr. But Deburr allows you to do more advanced toolpaths with a chamfer type of option using up to 5 axes. And for the Deburr Toolpath, we're going to choose the 3/8 ball, and we'll call this Deburr. And under the cut pattern, you can choose, for example, edge definition and part surfaces. So I'm going to select user defined, and we're going to choose edges. And we're going to start with this edge right here, and we're going to walk the way all the way around, grabbing this geometry. And you can also use the options up here for adjust or next. So I'm going to hit adjust and then next. And click OK. So that's the chain we want. And you can define the edge shape as to how you want this Deburr toolpath to cut into the material. And tool axis control, we're going to lock it to 3 axes. And let's just click OK. And in this case, as you can see, I missed machining surfaces, so I don't want to close it. I'm going to go back in and make that change now. And under the cut pattern here, part surfaces, we'll triple click to select the entire body. When we click OK, the toolpath will get calculated. And again, using the multi-axis toolpath license, we can now take a look to see how this Deburr toolpath looks. And it comes in and it machines the entire edge, including the 3D shape. And that's the benefit of the Deburr compared to the model chamfer. So in this lesson, we did everything from facing off the part to machining some pockets. We then explored some opti-rough and some opti-rest. And then we did some drilling as well as some chamfering of some areas, exploring the model chamfer tool and the Deburr tool. In the next set of lessons, we're actually going to flip this part around and work on the other side.